Hi everyone. Good evening. I'm Doni from AECC Indonesia, the moderator of today's webinar. And I'm glad to have all of you here virtually and welcome to this webinar. Also, we have Alan and Cynthia here, the recruitment team from Cranfield University, to answer all of the questions regarding admissions, scholarships, and all the needed information to study at Cranfield University. And today's webinar is about the advanced composite materials for aerospace, automotive, and engineering applications, brought by Dr. Samir Rahateka, research lecturer in manufacturing, enhanced composites and structure center at Cranfield University. Without further ado, please welcome Dr. Samir. Over to you, Dr. Samir.
Thank you very much, Doni, for that kind introduction. So it's exciting to be part of this seminar. We must thank the whole team, Alan, Tony, and certainly looking forward to participate and interacting with your students. So without further ado, let me share the slides we have for today's presentation. Right. Hopefully you can see it.
Yeah, yes,
wonderful. So this is a sort of, technical come a little bit of study seminar or study opportunity seminar from what we do in Cranfield. I'm going to talk about advanced materials and how they are used in various engineering applications. Because there's such a huge scope of advanced materials, perhaps I thought I will focus mainly on lightweight materials which are used for aerospace and automotive structures. So we'll use mainly advanced lightweight materials for the overview of this seminar. So myself, Dr. Samir Rahateka, we have Dr. David Eyre, who is the director for the Advanced Materials MSc program with us. And the head of our center is Professor Koziol. So he unfortunately couldn't be with us, but hopefully for future interaction, he will be with us. He heads our Composites and Advanced Materials Center, where this MSc program is located. Okay, so let's look at, before I go into advanced materials, I'd like to give an overview of what is, a little bit about Cranfield. Why is it so special? So location-wise, we are located about 40 miles north of London. London is somewhere here. 40 miles north of London and 40 miles west of Cambridge. So you can think of it as a southeast part of UK. Very nicely located, conveniently located close to London. So you can go to London within an hour, but not have to pay very high rent being in London. Okay, so nice location. In terms of facilities, that's our campus, Cranfield University campus. And what you're seeing here is the airport, which is part of our campus. So we are the only university in UK and possibly in Europe which has its own airport as a part of our campus, which is used for training facilities for aerospace as well as advanced engineering applications. Okay, so that's the airport, and that's the Cranfield University campus. Various department, manufacturing, aerospace, automotive, as well as management. So let's focus on first engineering part. So that's university campus, and that's the airport. It's an active airport. You can land a mid-size aircraft on this, and there are also some sessions for testing. If you were to test some parameters while flying, you can do that in using this airport facility. So historically, why there is airport on campus? So if I go back to the history of Cranfield, during World War, London was being attacked by of course, German forces, and it was not a safe place to train Air Force pilots. And that's why the Royal Air Force moved their training facility close from London to slightly north of London, which is about 40 miles in Cranfield. So historically, this university site was a World War II training site for pilot training. And end of the war, of course, there was an excellent facility. This facility was converted into Aerospace Institute and then into Cranfield University for aerospace and aerospace related manufacturing in general. So this is why, because of this excellent history tied up with aerospace industry and aerospace training, 50% of the postgraduates in aerospace in UK are from Cranfield University. So we make a big contribution for postgraduate studies in aerospace and manufacturing related subjects. Okay. So that's, you already saw that part. As a part of our, because of this excellent sort of track record and facilities, we were awarded by UK government 35 million pounds of investment for Aerospace Integration Research Center, AIRC, which is in collaboration with Rolls-Royce, Rolls-Royce engines, aircraft engines, mainly that sort of work, and Airbus. So they are the major industrial partners in this Aerospace Integration Research Center. And the idea of this or the focus of this Aerospace Integration Research Center is to take various disciplines of aerospace and manufacturing and then build something which is directly relevant and can be used for aerospace industry, rather than doing some basic work in lab or in academic setting, and that research may not be used for aerospace directly. So this is why Aerospace Integration Center basically takes the fundamental research in manufacturing as well as engineering facilities in manufacturing and integrates into aerospace technology to develop new products and new facilities which can be used for directly in aerospace sector with help of our industrial collaborators, Rolls-Royce and Airbus. Okay, so that's again funding from Airbus, Rolls-Royce, and UK government. So one feature of studying in Cranfield University is it's exclusively postgraduate. Having studied in a different university and worked in UK in a different university before coming to Cranfield, I can tell you it makes such a huge difference, because if you're studying in a typically undergraduate dominated university, the postgraduate numbers are relatively small, and therefore you do not get as much attention as undergraduate students, whereas in Cranfield, we do not have undergraduates. So all the attention of the faculty members as well as the facility access is for MSc and PhD students. And that way, students get much more student-faculty interaction as well as better lab exposure and better postgraduate study experience as a whole. In terms of QS world ranking, we are in top 40 in the sector of mechanical, aeronautical, and manufacturing. So world top 40 universities in this branch as per QS world ranking. So that is overview of Cranfield University. Now let's look at the research, because of course, besides knowing about university, I think this seminar should be about giving you some knowledge beyond just education and studying. Let's look at what composites are and what research we do in terms of materials and lightweight materials. So in our Composites and Advanced Materials Center, we look at right from nanomaterials manufacturing, carbon nanotubes and graphene. So hopefully you have heard about carbon nanotubes and graphene, excellent nanomaterials with versatile properties, right from very high mechanical properties in terms of using them as a structural materials, excellent electrical properties to replace electronic components, metal components. So we have one of the world leading facilities of manufacturing graphene from a biogas, waste gas. So very, very unique manufacturing process, which is led by our head of the center, Professor Koziol, where he uses methane, which is a byproduct from waste gas or sewage waste, and convert that methane gas into graphene and hydrogen. Okay, so if you want to study graphene or carbon nanotubes, nanomaterials, we are one of the unique universities where we can manufacture it using a trademark facility, as well as use them for manufacturing advanced materials like carbon fiber composites using carbon fibers and graphene and carbon nanotubes. And those components, we will call it as multi-scale composites, can be then used for aerospace sector. Okay, so most of you hopefully will know that carbon fiber composites are widely used in aerospace and motorsport sector due to combination of high strength and low density or lightweight. Okay, as far as I'm concerned, I work on both nanomaterials as well as use of natural materials, natural fibers like cellulose or tunicate is a sea creature, or hemp, flax, jute, which I'm sure in Indonesia there is plenty of natural fibers. So I also work on natural fibers and how to make use of natural fibers for making composites for low value as well as high end applications in advanced engineering components like this heavy duty vehicle or in helmets. Okay, so that's my research and our center research. Our center, as other centers in Cranfield University, work closely with industrial clients like Airbus, Bombardier, GKN, MBDA, BAE Systems. All these are aerospace companies. So we work closely with them. And because we are part of, Cranfield is part of Motorsports Valley, UK Motorsports Valley, within 20-30 miles of Cranfield University, there are a number of motorsports companies and motorsports related activities. And that's why we are called as Motorsports Valley. So lots of motorsports related companies, Lotus, McLaren, and companies which manufacture components for these two automotive companies, Hexcel, Cytec. And beyond that, we also work on soft materials like nanomaterials or biomaterials, where we also work in collaboration with Unilever. Okay, so in terms of lightweight materials, I thought it would be easy to, or it would be good before I talk about composites, what composites are. Okay, so essentially composites are carbon fiber or glass fiber. Typically, there will be other type of fibers as well. For example, natural fibers, but you take essentially continuous fibers, which are high strength, high stiffness, but lightweight, and mix them with polymeric resin like epoxy. And once you mix them, you can make a pre-preg from this carbon fiber and epoxy, which can be laid into and shaped into different components. And then you can heat this assembly to cure or cross-link the epoxy to get you a set product from composite, carbon fiber composite. So aircraft wings or fuselage or your helmet used for biking is all carbon fiber composites manufactured using these sort of pre-pregs and epoxy resin. Okay, you can do vacuum bagging. We have this facility in Cranfield, where you can then put this assembly into a giant pressure cooker, which puts a lot of pressure on these pre-pregs and heat it to get you a very low void content composite, which will give you high performance. Okay, there are other techniques by which you can manufacture composites, like glass fiber, infuse the resin. Rather than having pre-preg, you can take dry glass fiber fabric or carbon fiber fabric, or for that matter, natural fibers like jute, hemp, flax fabric, and then infuse polymeric resin like epoxy, like polyester, using resin transfer molding or resin infusion system, and then mold a component like boat hull or like helmets, So that's another manufacturing technique which we can do in our lab in Cranfield. Vacuum infusion, as I said, instead of resin transfer molding in a mold, you can have a vacuum bag and simply infuse the mold, the resin, and then you can make something like a boat hull from glass fiber or carbon fiber or even natural fiber based composites. Okay, so that's basics of composites, how composites are manufactured. Application in automotive sector. So this is quite exciting because so far composites were mainly used in aerospace components, right? So carbon fiber wings, carbon fiber composite wings, carbon fiber fuselage for aircraft manufacturing. But learning from that technology, there's also automotive sector, which is exploring use of carbon fiber for lightweighting the vehicles, right? So BMW i3 is made up of lightweight carbon fibers. So the whole frame of BMW i3 is made up from carbon fiber composites. By the way, if you have any questions, if you don't understand anything, please feel free to put it in chat box, even if it is very basic question, what composites are. This is what the session is about. We would love to have more interactive session. So any sort of question, even basic, are most welcome. Or if you have any curiosity or suggestion, more than happy to get those questions, okay? And we'll give at least last 15 minutes for Q&A. Right, so coming back to composites manufacturing, composites are used not just in aerospace, but now in BMW i3. You might have seen this model, but this is electric vehicles. And because electric batteries are heavy, they want to reduce the weight of the vehicle. And the only way they can reduce the weight is replacing aluminum or steel frame of vehicle with carbon fiber composites. And this is one example. One single frame made up of carbon fiber, if it is from steel or even aluminum, two people simply cannot lift it. Because if it is carbon fiber composite, it's extremely lightweight, and therefore it can be easily lifted. And this lightweight structure will reduce the weight of the vehicle, and therefore it will give you a bigger or larger electrical range for traveling. Okay, you will use less battery because your vehicle now is lightweight. Okay, so that's the main advantage of using lightweight structure in electric vehicles. You can increase the range. You don't have to put more batteries to increase the range. You can simply reduce the weight of the vehicle and therefore increase the range of your electric vehicle. So fuselage, another example of lightweight composites. It's made from mainly carbon fiber and epoxy composite. So most of the aircraft, Boeing as well as Airbus, the new generation after 2010, are essentially manufactured from carbon fiber and epoxy. Other giant structure. So 50-meter long wind turbine blade, okay? Extremely large structure, as big as a jumbo jet, okay? So that wind turbine blade is manufactured using mainly glass fiber composites, and more sort of advanced application for those who enjoy motorsports. Most of components in motorsports vehicle are carbon fiber composites, okay? So that's where lightweight structure like composites will have lots of advanced engineering applications, and of course exciting job opportunities in aerospace industry, in wind turbine manufacturing industry, as well as motorsports industry. Right, I'll give you some typical examples we've manufactured from our center in Cranfield. So the Composites and Advanced Materials Center in past was collaborating with BAE Systems, which is a defense aircraft manufacturing company. They basically, when I say the center, one of our faculty members, Andrew Mills, he was involved in collaboration with BAE System, where he manufactured the airframe of this UAV. Okay, UAV now is very common, but this was about 10 years back. UAVs were not that common. And that time, this was a pioneering work where we manufactured the frame of this UAV. So we don't do work only on small scale, but we believe in working with industry directly, manufacturing components which can be directly used by industrial partners. And that gives us a unique advantage in terms of working with industry, as well as for students to interact with industrial partners for their career opportunities. So this is again part of, you can see the scale is not small. This is a wing box of aircraft. So about 2 meters long, about 1 foot thick, composite from carbon fiber, manufactured using funding from a UK government project where lots of UK universities as well as industrial partners were involved for manufacturing lightweight wing box, which can be crack resistant. Okay, another type of composite. This is instead of traditional design of wind turbine blade, this is a horizontal wind turbine blade, where this might give you certain advantages in terms of higher efficiency of rotation. So this is a wind turbine blade which was proposed as a concept, and instead of just concept, we said, okay, let's manufacture this and show whether it is possible to manufacture this component. And you can see this is a very large wind turbine blade as per this concept, and was manufactured with help of a couple of our faculty members, Andrew Mills here, and our head of the composites manufacturing technical facility, Jim Hurley. They manufacture this component about 30 foot long. So quite an exciting project. And it gives you an idea that, it's not academic work. We do real life, large scale component manufacturing, which is an excellent training sort of ground for anyone who comes and studies with us. Right, so I'll very briefly mention about graphene manufacturing for those who are interested in high-tech novel materials, how to manufacture graphene, not using graphite, but using waste gas. So, biogas is produced from, waste product. So cow dung or, food waste produces methane. So it's basically a waste gas, which is also a greenhouse gas. So if you take that waste gas and break it down chemically, it's basically carbon and hydrogen, and convert the carbon from methane to graphene using plasma reactor. Our head of the center has this excellent technology where they can take waste gas like methane from city waste or from cow dung, and then convert that methane into graphene using a plasma reactor, and the byproduct will be graphene. So the main product will be graphene and the byproduct will be hydrogen. So not only you get graphene as a high performance material, but you also get hydrogen as a fuel for clean burning and renewable fuel, which is less polluting than other type of fuels. Okay, graphene, for those who don't know, is one of the best higher strength material, which can be used in aerospace components, space technology. It also has one of the highest level of conductivity, electrical as well as thermal conductivity, and therefore it can be used in electronic components. There are already electronic companies which are replacing a lot of electronic components with graphene based products, which gives them better performance. And there are also companies which look at graphene as a material for heat transfer, effective heat transfer for engine cooling, for example. Okay, so that's why graphene manufacturing is very important. And here in our lab, we have shown how to manufacture graphene using a waste gas, giving you a high value product with hydrogen as a byproduct. So that's how graphene looks like, molecular size. Essentially, it's a single layer of carbon atoms, and that has excellent modulus in plane. Okay, so exciting material, lots of uses in advanced materials and engineering applications. This is specifically work in which I do as a part of my research. So for those who have studied composite already, they can recognize this image. Just to introduce what composites are, these are basically fiber which are glued together using epoxy resin. So these fibers are embedded in a polymer resin, and they're glued together. So the fibrous part is carbon or glass fiber, and this part, which doesn't look like fiber, is a glue like epoxy or polyester, which binds these fibers together. So what happens is the fibers are strong and the glue which binds them is lightweight. So therefore you get a composite which is strong and lightweight, because the resin which binds it is extremely lightweight, and so is carbon fiber. So it's excellent material for aerospace. But the problem with this material is that the glue which binds these fibers together are not as strong as carbon fibers. So whenever there is failure of this material, it usually happens within the glue. Okay. So how can we avoid failure? The way to avoid failure is to make this glue or epoxy or polyester resin, which is used as glue, stronger. So how can you make glue stronger? We disperse graphene or carbon nanotubes within this resin. So the resin properties will also be increased. So this is one example. This is a cross section of this composite. These are carbon fiber or glass fiber, and the region between them is basically epoxy or polyester resin. Now that resin is mixed with carbon nanotubes or graphene. You will have gaps between these carbon fibers filled with epoxy and carbon nanotubes, which are much stronger than the baseline epoxy. And therefore you can get better mechanical properties compared to just using epoxy as a glue. Okay. So why is it important? Because more than 50% weight of your aircraft is made from composite materials like carbon fiber. Okay. By volume, it's much, much more, but you can see pretty much everything is blue except the engines. That's because most of the material used in new generation of aircraft is composite materials, lightweight structure. If you look at a defense aircraft like Eurofighter Typhoon, more than about 70% by weight is carbon fiber. Okay, and remaining 12% or most of it is glass fiber. Only the engine part is made from titanium or aluminum alloy. Okay, same with some other aircraft beyond Eurofighter that also has a large component of it manufactured using carbon fiber and Kevlar fiber as well. Okay, so why is it important to study and increase the strength of composite materials? Because composite materials, of course, they work very well in plane, but out of plane, within the layers of composite materials, they can delaminate. So this is not going to happen easily, but when they fail at very high load, they fail because of this interlaminar delamination. Okay, why does delamination happens? Imagine the situation. The reason why the airport authorities don't allow birds to come close to airport is because when you take off and land, if the bird strikes the plane, it's going at 300 miles per hour, 400 miles per hour, and even a small bird can damage the plane quite a lot at that speed. Okay, if your speed of aircraft is very high, even small object can damage the aircraft. And when there is this sort of damage, there is delamination of composites. Okay, in normal situation, it will be perfectly fine, but something like bird strike can really damage your aircraft. So how can you avoid that sort of damage? You cannot avoid bird from flying. There may be some bird during takeoff and landing. Even if you try hard, this could happen and does happen. So how can you overcome this problem? Before we go into solution, this sort of delamination also occurs during repair. So if you are repairing aircraft component, there may be some damage to the aircraft, or you want to modify the aircraft, add some extra component to it. So you are drilling a hole. During drilling a hole of aircraft, there may be some damage below the surface. There may be delamination of your composite. So there will be a crack during either bird strike or drilling, and this is not on the surface. So surface, visually it looks nice, but below the surface there are cracks which can grow and cause damage below the surface of your composite. So how can we avoid these cracks from growing and propagating as you use this aircraft? So instead of using just carbon fiber and epoxy, as I mentioned before, if you mix epoxy, the glue, with carbon nanotubes or graphene, if there is a crack going between the fibers, the crack will get trapped. Okay, because of the presence of this high stiffness, strong carbon nanotubes, and therefore the crack propagation will not be as quick, and that will increase fracture toughness or reduce the delamination of composites. Okay, this is what carbon nanotubes and graphene after mixing with traditional composites can do to reduce the damage due to crack propagation in composites. So I'm happy to answer the question later on, but this is quite an exciting area. We work quite a lot on it for last 10 years. So in future generation of composites, the crack propagation will be reduced if you were to use nanotechnology for aerospace applications. How do we do it? Very briefly, we take a suspension of carbon nanotubes in a simple solvent like ethanol, use that ink to coat a surface of, in this case, glass fiber composite. So original color here was this sort of, red. And if you coat it with carbon nanotubes, it becomes black. And then we make a composite from it. And what we found from our research is that if you use just a composite without carbon nanotube modification, you have between two layers. This is one layer of composite, and this is a second layer of composite. When you join them, there is a region where there are no fibers, okay, only glue. Okay, so that's this region, resin rich layer, and that is easy to fail. Or when I say easy, it's less strong than this region. But if you add carbon nanotubes in this region, that is shown by this, the colors are not true colors, they're just highlighted to get you a better visualization. But now with carbon nanotubes between this joining layer, this layer becomes stronger, and therefore you can get better mechanical properties by adding carbon nanotubes between two layers of composite. And you can really increase the fracture toughness. Okay, so this is without carbon nanotube reinforcement. You can see two layers of composites. They separate quite easily, whereas if you add carbon nanotubes, they bridge between the two layers of composite, and you can see a lot of glass fibers bridging across these two layers, which reduces the crack propagation. Okay, and that's why you get stronger and tougher composites. We published this paper about 10 years back, and there are many more. So happy to talk about this. Other challenge in composites or advanced materials for aircraft is the lightning strike. So I don't think I have too much time, but I'll very briefly mention, when you fly at high altitude, the aircraft will get lightning strike once a year on an average. And when there is lightning strike, your surface can be damaged quite a lot. So we have a technology, or we are currently studying how can we use carbon nanotubes to coat on the surface of composites and reduce the damage from lightning strike. So there is some promising method for using this for lightning strike damage protection. Okay, a company like Airbus will be very much interested because this is a ongoing challenge for them. Right, so I'm going to switch the gear now. So first part, I spoke mainly about aerospace composites. Now I'm going to talk about renewable composites, because I know in Indonesia, there is a lot of work and a lot of resources from natural plants, natural fibers. So I wanted to quickly discuss about natural fibers and how natural fibers can be used for making composites for building construction and automotive components. Okay, so let's look at this case study briefly. Why using natural fiber is important? Because we can't just use materials which are not renewable. End of life, if they don't biodegrade, there is a problem for any sort of industrial application, whether it is automotive or aerospace industry. And the UN Sustainable Development Goals, for those who have seen those, require companies to use sustainable material as much as possible. Okay, so how can we use sustainable materials for construction engineering? Use natural fibers like bamboo, flax, hemp, and combine it with epoxy resin to make these sort of roofs, which typically are made from metals or from, in some cases, or in especially developing countries, from asbestos, which is banned in Europe, but they still use asbestos. Here, we can use natural fiber and epoxy composites for making rooftops, and wood plastic composites for flooring. Okay, so what we have done in our study is basically looked at cork. So you may have seen cork in bottle caps or cork in some sound absorption application. Cork basically comes from a tree bark. Okay, the skin of the tree, when you peel it, it has this sort of, cellular microstructure, and that's why cork is very good at absorbing energy and sound. Okay, so we use cork as one of the materials for manufacturing composites. It is flexible and has excellent ability to absorb energy and also good thermal insulator. And then we used flax fibers as other sort of fiber. Instead of using carbon fibers, we used flax fibers for manufacturing composites. We also use non-halogenated flame retardants because natural fibers are flammable. So therefore, we need to reduce the flammability of natural fibers by using some sort of flame retardants. In this case, we have used aluminum trihydrate to reduce the flammability. Okay. And by using these two elements, we manufacture something called as sandwich composites. Okay. Sandwich composites are structures where you have core typically made up of foam or lightweight material, which is typically energy absorbing. And the skin of the material is strong, stiff, and high modulus. So you can get high strength and stiffness from the skin and high energy absorption from core. And there are various types of sandwich composites, which are mainly used in bridge flooring, decking for ships, decking for aircraft or aircraft floor panels. So quite sort of widely used sandwich composite structure. What we have done in our study is, instead of using carbon fiber, we have used flax fibers as a skin with epoxy resin as a skin of this composite, and the core is made up of cork material. So you can think of almost like a cross section of a plywood, right? Plywood, you see mainly wooden component, but here, instead of having a normal plywood, we have a skin made up of flax fibers, and core of that plywood is made from cork material. So skin will be strong and the core will be energy absorbing. Okay, so here is one video I wanted to quickly play. This is, when you hold this material, it is almost as stiff as plywood. Okay, so if you put 1,000 kilograms of load on it, of course it will bend, but it will not break. So if you put 1,000 kg of load on a plywood, it will simply snap in two pieces. But in this case, if I put 1,000 kg of load on our sample, it doesn't break. It will bend, but it will not break. So you can think of it as a stiff material to begin with, but if you apply 1,000 kg of load, it will not snap because the core is energy absorbing. Okay, and that's why it will not snap like normal wood. It will be as stiff as normal wood, but it will not snap because the material inside is cork and it is highly energy absorbing. Okay, so you can use this as a new generation of plywood, which will be as strong as plywood, but will not snap into two pieces, unlike plywood for construction applications. Okay, it is flame retardant, or we have made it flame retardant. So just to give you an idea, this is the flame retardant sample. Okay, so you can make it such a way that it will reduce its flammability. I'll be happy to talk with you later on about this. So end application of this: train floor panels, bus floor panels, plywood replacement, claddings, roof structures. So many plasterboard, many applications of this. So using natural materials, application in construction as well as in transport sector. Okay. One topic or one project we have been looking at is how can we use composite materials in sports vehicles. So this is an example of Jaguar F-Type, uses carbon fiber roof, but carbon fiber is very strong, stiff, lightweight, but it will not absorb the vibration. If you have a big truck passing through the Jaguar F-Type, the roof, if it is made from just carbon fiber, will start vibrating. And that's not a good feeling if you're paying 70,000 pounds for this car and the roof is not stable. That's not a good thing. Okay, so what we are looking at is if you can make carbon fiber sandwich composite with core made up of cork. Okay, if you use a cork material, you will have stiff carbon fiber on the surface, and cork can absorb energy and vibration, and therefore your roof of that car will be strong, but also will absorb vibration energy and will be more stable. Okay, so that's all from me on the technology part. I'm going to give the floor to our Director of Advanced Materials MSc program about what we offer in this MSc program. All these composite materials, of course, will be explained as a part of our MSc course. But there is a lot more than just composite materials in Advanced Materials MSc. So I'm going to pass on this the floor to David, Dr. David Ayer, who is the Director of Advanced Materials MSc program.
Thank you, Samir. You have had several questions come in which I've answered during the presentation. I think we're going to return to questions later, but I'll just spend 5 minutes giving an overview of this, the advanced materials delivery. And what we should say is that our taught courses are informed by our research. What do I mean by that? I mean that we bring our research into our taught courses. So we will talk about new developments within the taught modules, but we'll also have projects. The projects will adopt the research projects that are already running and run the MSc students to progress our research, not to do research that's already been done. So everything is new at Cranfield. Can we move on to the next slide, Samir? Thank you. So we have 3 components on our 1-year MSc. We have our 8 taught modules, which are delivered from October through to the end of January. Then February to the beginning of May, we'll deliver our group project work. And then from mid-May through to the end of August, we'll deliver our individual research project, and wrapping everything up early in September. So that's the final oral examinations and report submissions. Next slide, please. Yes, I just to give you an idea of the weighting, we have the modules that are worth 40%, the individual research project that's worth 40%, and the group research project that's worth 20%. But we should stress that all of them are focused on advanced materials and giving you an exciting introduction to the world of materials and how we process them and how the properties can be modified. And Dr. Rattiker has already talked about modifying the properties by blending the cork with the carbon fiber epoxy structures. And there's an infinite way of developing our vast range of materials. Next slide, please.
I'll just add one point quickly. So
Yes.
If you look at most of the, thank you, David. If you look at most of the MSc courses beyond Cranfield, the stress will be on taught courses. So you will be spending more time in the class, learning things in class rather than in the lab. Whereas in Cranfield, we believe that you learn better in the labs. And that's why you see 60% weighting for the MSc course is for research projects, group research project and individual research project combined. So you learn quite a lot being in the lab, whatever is taught in class. Okay. And that I think is a unique sort of offering, which David, I'm sure, will explain about group projects and IRPs. Excellent, excellent opportunity to interact with industrial clients and industrial career opportunities through the group research project and individual research project. Having looked at a few other work beyond Cranfield, I think this is quite unique structure. So thank you, David. I'll go for the next one.
That's great, Sunny. So this slide's just giving you an overview of the materials course. So on the right-hand side, we have the 8 taught modules. There's some images dotted around there to show you the areas we're looking at. So composites, we are part of the Composites and Advanced Materials Center. So there is a huge focus on polymer composites, But metallics, you've got to know about metallics and how they behave and how you manufacture those. So the top left image is a metallic part, but it's a metallic part that we've developed to integrate with composites. So we're looking not just for an adhesive bond, but a mechanical bond by having a structure that will integrate with the composites. And then the third image down on the left-hand side is showing testing of this composite metallic joint, which is using the equipment at Cranfield University. I should say the composite joint was built at Cranfield University. The structure was, some of it is done at Cranfield University, but we have good ties with Sheffield University and the Advanced Materials Research Centre up at Sheffield, and a variety of other research institutes which we can call on to help us there. The image right at the bottom, the left-hand corner, is I think that's the Mercedes car. It's from a long time ago. It may well be a McLaren, but we do have links with Mercedes, McLaren, Lotus, Red Bull, and the big image at the bottom is showing the suspension struts of a Formula One car, which are predominantly carbon fiber, and they're carbon fiber because not only are they lightweight, but they're super stiff. Unfortunately, as Dr. Rattica was telling you, they do tend to fragment on impact, and that is an area that we continue to investigate, damage tolerance. And the damage tolerance comes in with the failure of materials and structures. But within the centre, you do have opportunities to manufacture the composite parts, test the composite parts, and then critically analyse why they're failing, how they're failing, and how we can improve. Looking at the taught modules, an introduction to materials engineering just reminds everyone of the basic properties of materials. Then we have additive and subtractive manufacturing, looking at metallics predominantly. Failure of materials and structures really gets into why materials fail, whether that's under static loading or dynamic loading. And you will hopefully develop your ability to design with these materials and avoid failure. General management gives you an introduction into budget control and man management. Composites manufacturing will really give you the whole range of polymer composite manufacturing techniques, and they are vast. Finite element analysis, it's always a good tool, and I saw on the question and answer board that someone was asking about finite element analysis. It is a tool. It is not the beginning and the end. It is more, you design a structure, you test it on the software, the finite element analysis. If it fails, you go back to the drawing board. If it passes, then you need to test it in the lab, because you cannot rely on numerical analysis to find all of the problems. A material selection gives you some guidance in what you need to consider when you're trying either to identify a material for a new application, or perhaps identify a better material for an old application. And we've covered several in this presentation, where we've looked at composites rolling into electric vehicles, composites expanding into the aerospace market, composites having a foothold in the renewable energy market, etc. Surface science and engineering is focused on mainly on aero engines and the physics and requirements of materials working in jet engines, predominantly the hot area. How do we make a jet engine more efficient? The simple answer is increase the temperature. What's wrong with increasing the temperature? Well, a lot of materials don't like to go beyond 2000 degrees C. How can we push the barriers? Ceramics are amazingly good at working at high temperatures. So if we can marry ceramics up with metallics and composites, perhaps we can have the next generation of super efficient engines. Next slide, please. This slide is just trying to put it in perspective, the way we deliver the course. And as Dr. Rattika said, our pride of the course is our group project and thesis project. So we will cram students with knowledge in the first 3-4 months, October to the end of January. You really do have to study hard. And then the following 8 months, you spend applying the knowledge that you've gained elsewhere and the knowledge you've gained at Cranfield in project work. Many of the projects have industrial sponsors. All of the projects have industrial focus because Cranfield is a very industrially or high application relevant university. So we're trying to develop materials which are going to be used in the next 5-10 years, not in the next 20 years.
Sorry.
That's okay. I was just thinking what else to say. We'll leave that for questions. We'll move on to the next slide. I always stress with the students coming in every year that the time at Cranfield is more than just the MSc study. So there's lots of opportunities for developing networks, learning about other things. So we try and put on informal seminars throughout the year. We just had one delivered on nanomaterials last week to the students. We try and bring in guest lecturers who may do the informal seminars, or they may be delivering into the taught modules. We try and have as many of our projects directly sponsored by industry, so that you will be talking to the industry representatives about the project, getting the briefing, developing the project, and delivering the answers. We have several student exhibition days. So we have a group project exhibition day at the end of April, and we have an individual research project exhibition day at the end of August. And as Dr. Rattika said, we're quite well positioned within the UK. Every year there is an advanced engineering show up at Birmingham, which is, I think it's less than an hour's train ride from the university. And I think it's every 2 years there's a manufacturing exhibition, MAC exhibition. And last year, Farnborough Air Show was returned. It's on every 2 years, when COVID's not around. And we took 3 coachloads of students to the Farnborough Air Show, which was a huge success. The students really enjoyed not only seeing the flying displays, but walking around the exhibits and finding out a bit about how old technology is used, how new technology is used. There was a fascinating presentation by a biofuel manufacturer. There was a company demonstrating not flying, but showing off their jetpack. And I had a long conversation about the materials that are involved in this jetpack. We are hoping to invite the inventor to come and talk to our material selection students in January, because it's highly applicable. And just to give you an idea of the sorts of companies that we deal with, but this is not an exhaustive list. These are companies that we've had projects from in the last 5 years. And we do have regular clients: Airbus, BAE Systems, Unilever, Rolls-Royce, to name a few.
Saffron.
Have we got another slide, or is that the last one?
Yes. No, we have a few. So I will briefly explain about this one as we did in our previous presentation. So last 2 years, UK government has changed their MSc policy or their postgraduate education policy. So MSc students which graduate from UK, from recognized universities, of course, they are entitled to get a post-study work visa. So many of you may be aware of it, but 2 years back, the students who graduate from UK, international students who graduate from UK, were supposed to go back to their countries unless they find jobs in next 3 months. Whereas now they have given you opportunity to work for 2 years in UK for a post-study work visa experience. So after completing the course since 2021, they're eligible to apply for a 2-year graduate training or graduate work experience visa. Okay, and that makes all sort of a big difference in terms of your career opportunities. Most of my students, international students who were going for after completing the MSc, they would get lots of interviews, but many of the employees in past were not able to sponsor visa. Now that problem is not that, so it's not such a big problem, because for 2 years you can work for this company without having to sponsor a visa for you. So that's makes a big difference, and hopefully that will give you as an excellent opportunity to study in UK as well as work to get a valuable experience. I think tuition fees, you can find the details. This tuition fee and living cost is about 12,000 pounds. There are limited scholarships via Global Manufacturing Leadership Scholarship. So we do offer a full, limited full scholarships, which is called Global Manufacturing Leadership Scholarship. So by all means, do apply for it. And the deadline is, David can tell me, but I think it's early next year. Besides this global manufacturing scholarship, we also give partial scholarships like 20% tuition fee scholarship or up to 50% tuition fee reduction scholarship. So there is those opportunities as well. So more than happy to answer your questions on that. So there are limited full scholarship opportunities, but a number of partial scholarship opportunities, which I'm, and David and I will be happy to answer any questions around it. Students can work up to 17 hours a week, although you have to make sure that you are balancing your work and studies very well. But legally, you are allowed to work 17 hours per week if that helps cover your tuition fee and living expenses. And there are a number of students which do work on campus. In terms of final career opportunities, 96% of our graduates were employed within 6 months of completing their degree program. So that gives you an idea in terms of how well the students are doing. There are career opportunities. So we have career support center, so they can help you with your CV improvement, getting connected with your alumni, making sure that you have best presentation skills during your interview. And that all plays an important role towards your future career employment opportunities. So that's where we'll stop, because we really want to take questions. There, I see that there's a lot of chat, a lot of suggestions. We might run over, by a few minutes, but we would love to take all those questions. So let's start with Q&A. Alan, if you are okay with moderating Q&A session.
Yeah, of course.
Alan,
yes. I think. Thank you so much, Samir and David. I believe David has been helping with lots of the interesting questions in the Q&A box already. So thanks so much about that, David. And I think we have got a few remaining questions, and I would just pick some of them. I think this one coming asking, is there any research with 3D metal printing?
So David knows this more, but we have a lot of research work on 3D metal printing through which is an extension of welding technology. So you can think of welding as sort of printing technology, although it's in one dimension. There is research facility on three-dimensional welding, three-dimensional metallic printing. So yes, if you are interested, you can pursue a group project or research project through it so to answer your question, yes, there is facility, and there is also research projects in that direction if you are interested. I don't know if David wants to add something in this.
Yeah, sorry, I was answering a question at the time. What was the question again?
So the question is whether there is
3D metal printing.
yeah.
3D metal printing. So that's a very good question, because it's done on several sorts of levels. So we've got well-established companies that do 3D metal printing from powder. And within our manufacturing technologies, additive and subtractive manufacturing technologies, the students will be introduced to that. And we also have good relationships with a company in Wales that builds these machines, and it Renshaw, I think they are. It's not, I work mostly with the polymers, so it's not an area that I know. But then Cranfield University is renowned for the wire arc additive metal technology, which the head of the Welding Engineering and Laser Processing Centre, Professor Stuart Williams, is developing that and pushing it into the aerospace industry. So instead of making titanium parts out of a great big chunk of titanium and machining it, you start off with titanium wire and you weld it together to form the part, and therefore you're reducing your energy required. So you will find that at Cranfield, we very much have sustainability in everything we do. So we're always looking for opportunities to reduce carbon emissions and make manufacturing more sustainable. I don't think I've got anything else to add to that.
I think this is excellent. Yeah, I mean, bottom line is there are excellent facilities both in on campus as well as industrial collaborators. So yeah, happy if you have further question on this, very happy to discuss offline. I think I'm seeing, sorry, I don't want to interfere with Alan. You go ahead, Alan. It's your
yeah,
section.
thank you, David, and thank you, Samir. I think we could also share our email contact here for those students that are interested in an offline discussion about some technical questions with Cranfield here. So I'm just very quickly, because I'm a bit concerned over the time here. We are 5 minutes over time, but I think we can do one more questions before we go. So there's a question about a student interested in elastomers, and he's got a master's degree in chemistry and then been working in the Uber company for about 8 years. So he's wondering what are the chances or what are the opportunities here for research for PhDs at Cranfield?
So I'll just briefly address it, and David, you're welcome to add on this. We have excellent work on, so just to give you an idea, our head of the center works on new generation of elastomers manufacturing using, spray coating method, 3D coating method, and that manufacturing process reduces the use of basic material by many percentage. Significant reduction. They got a huge funding on it. I don't know if there will be funded PhD opportunities. We'll certainly encourage your government to sort of look into government sponsored funding. So in principle, or I know for sure, there is a lot of exciting work going on rubber research, rubber reinforced with graphene research. So there are PhD opportunities. We would love to explore funding opportunity both in UK as well as from Indonesian government. So please send us an email.
Perfect.
Yeah, sorry, Alan. Just to add to that, exactly. There's always opportunities. What I would say to your audience is, if you're going to do a PhD, if you're thinking about further research, it is 3 to 4 years of real commitment. So you need to make sure that you're doing the research in the area that you want to do. We at Cranfield, we've got enormous resources. So, and we can tailor a project to your requirements if you've got research backing. So if your government is giving you a scholarship, or perhaps the company you're working in wants to develop relationships with Cranfield and can fund it, then come and talk to us. But yeah, we are developing our skill sets within working with the elastomers. So please do talk to us.
Thank you, David. Thank you, Samir, again. And I think we've answered our last questions. And I've also shared some of the important information in the chat box as well, including some of the links for the scholarship for our MSc courses. So for those of you interested in applying, and please do look at it, the information that I've just shared in the chat box. I have also shared Samir's email address in the chat box. So if you got any further discussion, you want to reach out to Samir, please do feel free to do so. And last but not least, I've also shared our emails for Southeast Asia at cranfield.ac.uk. So any question regarding applications or scholarships or accommodation, etc. So please do feel free to contact us in the international team at Cranfield University. And last but not least, we must thank our colleagues here from AECC, Tony, obviously, for arranging these webinars. Thank you so much for your time, and I believe you will be following up with most of the questions and then the students' applications later on as well. So any of the audience that are interested in applying in Cranfield in the MSc courses or maybe the PhD courses, please do feel free to reach out to the team at AECC as well. Tony, anything else from you?
Yep, all good. Thanks, Alan. So for those who are interested to study at Cranfield University, either for MSc or PhD program, feel free to discuss your study plan with AECC Indonesia expert counselors for free by clicking link in the chat box. Yeah, feel free to book an appointment with us. Yeah, Dr. David.
Yeah, just a quick one. So one of the audience did ask if they could have a PDF of the slides. So the question is, who should we pass the PDF to so that you can circulate it?
Tony,
Yeah, sure.
can you do that?
Yeah, I can. I'll send all the attendance emails for you, so you can send all the PDF to them as well.
Perfect.
Yeah.
Thank you so much, Tony.
Thanks. So yeah, that's all, I think, Dr. Samir.
Yeah, I'll just make one last comment. I shared the link for the Advanced Material MSc in the chat box. So if you can share that with the students, that will be really helpful. So if they are interested to know more about the Advanced Material MSc, they can go to the website and find out more.
Got it.
Yeah, share. Okay. Yeah. Thank you once again, Dr. Samir, Dr. David, and thank you once again, Ellen, and thank you, Cynthia.
Thank you.
Thank you so much.
Thank you.
Hopefully,
Thank you. Have a good weekend. Yeah.
Thanks,
hopefully see you
Cynthia.
at Cranfield soon. Have
Yeah,
a nice weekend.
Yes, no, looking forward. Thank you guys, everyone.
Thanks,
Bye-bye now.
everyone.
Thanks,
Have a good
everyone.
weekend. Bye-bye.
Bye.